In this lesson, we're going to solve quadratic equations using our fourth method, quadratic formula. When we see that we have a quadratic equation, meaning we have an x squared, we're going to first of all set everything equal to 0 and write it in standard form. Now, we've already talked about the fact that you should see if it's factorable, and if it is, factor, because it's faster. Use the square root property if you just have an x squared and no x. Completing the square has to be set up so that you have a plain x squared, the a equals 1, and b is going to be even, and then completing the square is actually probably the fastest way. The last method that I would try is the quadratic formula. It works for every quadratic equation, however it's tedious and it's easy to make a mistake. The quadratic formula says the solutions to ax squared plus bx plus c equals 0 are x equals negative b plus the square root of b squared minus 4ac all over 2a, and x equals negative b minus the square root of b squared minus 4ac all over 2a. You'll notice that I have a plus here and a minus here, otherwise they're exactly the same. A lot of times you'll see this written as negative b plus minus the square root of b squared minus 4ac all over 2a, which is fine. You can use that notation. It's a lot easier, especially when you have an irrational solution. Just remember that you actually have two solutions to your quadratic formula. We should always come up with two solutions. So here's an example of a quadratic equation that we're going to solve using the quadratic formula. It's 3x squared minus 7x plus 4 equals 0. The way I always like to start these is to figure out what is my a, what is my b, and what is my c, and then plug into the formula. If you need to remember this formula, my suggestion is you write the formula over and over and over again for every problem that you do, and eventually you'll get to a point where you just remember the formula. So my a here is 3, and my b is actually negative 7. Don't forget that negative, and my c is going to be 4. So when I use my quadratic formula, and I'm going to use the shortcut with the plus minus, I'm going to have the opposite of negative 7 plus or minus the square root of the quantity negative 7 squared minus 4 times 3 times 4 all over 2 times, a is 3. Okay? And now this is why the quadratic formula is not my first choice, is I need to simplify this, and it's easy to make a mistake. So I have the opposite of negative 7, which is 7, plus or minus negative 7 squared, which is 49, minus 4 times 3 times 4, which ends up being 48, all divided by 6. So I have 7 plus or minus the square root of 1 divided by 6, which is 7 plus or minus, now the square root of 1 is actually just 1, all over 6. And here's where I can come up with my exact two solutions. So in one case I have 7 plus 1 divided by 6, which will be 8/6 or 4/3. And in the other case I'm going to have 7 minus 1 divided by 6, which is going to be 6/6, which ends up being just 1. So my two solutions are 4/3 and 1. What that means is that x can either equal 4/3 or it could equal 1. So if I go back to my equation and I plug in, let's try 1 because it's easier. Plug in 1 for my x here, I get 3 minus 7 plus 4 equals 0, and that definitely works. The 4/3 is going to be a little bit harder to check, but you can check that on your calculator. Now, I will say you'll notice that both my solutions are what we call rational numbers. This could have been factored in the first place. I could have gone and factored this trinomial and come up with these same two solutions by using my factoring method, which would have saved me a whole lot of time and work, but some people don't really enjoy factoring that 3x squared type problem, so the quadratic formula is not necessarily a bad choice on this one. Okay, we'll solve this quadratic equation using our quadratic formula as well. So in this case we have 3x squared plus 2x plus 2 equals 0. So my first thing that I want to do is write a equals 3, b equals 2, and c equals 2. So I don't have any negatives to worry about this on this one. So let's just write our quadratic formula so that we don't forget it. And now all I'm going to do is plug in. So I have negative 2 plus or minus the square root of 2 squared minus 4 times 3 times 2 all over 2 times 3. So if I simplify here, I have negative 2 plus or minus 2 squared is 4, minus, and notice that stays minus here, I have 4 times 3 times 2, which is 24 all over 6. So here I'm going to get negative 2 plus or minus the square root of negative 20. That may cause some problems. Divided by 6. So what happens when I have the square root of a negative number? I end up with an imaginary number or an imaginary solution to this equation. In this particular class, you don't have to worry about writing this as an imaginary number. You can just write no real solutions. But sometimes you do have to write these as what we call complex numbers, which includes real and imaginary. So if that's the case, I'm going to keep going here just to show you what would happen. So I know I have negative 2 plus or minus. This square root of negative 20 is going to end up being an imaginary number. So what I have here is square root of 20 is actually 2 square root 5, but because of the negative, it's going to be 2i square root of 5 all over 6. And now what I want to show you is if I do have to simplify this one, what's going to happen is I can't just reduce the 2 with the 1 2 with the 6. What I'm going to need to do is, technically what we do is we factor out a 2, and I would have negative 1 plus or minus I square root of 5 over 6, which ends up giving me negative 1 plus or minus I square root of 5 all over 3, because I can reduce the, let me use a different color, the 2 with the 6, and so I end up with just negative 1 plus or minus I square root of 5 over 3. And a common mistake is that people reduce that incorrectly, and you need to be very careful about that. But remember, in this class, we're not going to look at imaginary solutions, so you can just say there are no real solutions. There are solutions, they just happen to be imaginary. In this particular example, this is truly a problem that I would use the quadratic formula for. Because of the fact that I'm dealing with a 3 here, I don't want to use completing the square. It's not factorable because I'm coming up with imaginary solutions. So really the best method to use here is the quadratic formula, even though it can be somewhat tedious. In this example, I threw in a couple decimals, so you can see that using the quadratic formula really isn't any harder with some messy numbers. So here I have a equals 1, b equals negative 1.8, and c equals 0.81. So x equals negative b plus or minus the square root of b squared minus 4ac all over 2a. So I have the opposite of negative 1.8 plus or minus the square root of negative 1.8 squared minus 4 times 1 times 0.81 all over 2 times 1. So I'm going to use my calculator here for some of these calculations. I have 1.8 plus or minus the square root negative 1.8 squared. Remember putting that into your calculator. Don't forget your parentheses. So you'll get 3.24. It's positive. Anything squared is positive. Minus, and then if I take 4 times 0.81, I actually get 3.24. And that's going to all be over 2. So what happens to what's underneath that radical? I have 0. And the square root of 0 is just going to be 0. So you'll notice I get 1.8 divided by 2, which is 0.9. I only got one solution. I should come up with 2, and it's a quadratic equation. But what ends up happening on this one is I'm going to go and I'm just going to use kind of our factoring method, because this technically is factorable. It's not super easy to figure out how to factor this, but it is factorable. What multiplies to give me 0.81 and adds to give me negative 1.8? It actually is 0.9. So I have negative 0.9 here and negative 0.9 here. 0.9 times 0.9 is going to give me 0.81, and negative 0.9 plus negative 0.9 is going to give me the negative 1.8. So you'll notice that both of my solutions are exactly the same. So I do have two solutions. They just are the same exact number, so I only need to write it one time. In this last example, I'm going to point out a few places that people struggle with using the quadratic formula, but this particular example, you don't have a choice. Really, you have to use the quadratic formula or completing the square, which is actually worse in this particular case. So here I have a is 2, b is 4, and c is negative 7. So my x equals negative b plus or minus the square root of b squared minus 4ac all over 2a. Hopefully by now you're getting the hang of this quadratic formula. So here I have negative 4 plus or minus the square root of 4 squared minus 4 times 2, and notice that c is negative, so that's a negative 7 in there, all over 2 times 2. So be careful when I simplify this. I'm going to have negative 4 plus or minus the square root. This will be 16. This changes to a plus because of the fact that I have a minus and then a negative in here. When I'm multiplying, I'm going to get a plus there. So watch out for that. And I end up getting 56 all over 4. Okay, so if I keep simplifying here, I'm going to get negative 4 plus or minus the square root of 72 all over 4. Now, this is an answer that you can leave, but it's not completely simplified. So if you were dealing with a multiple choice question, this answer would not be there. I actually need to simplify the square root of 72 and then see if I can reduce it all. So off to the side here, I'm going to go 72, 2 goes into there, 36, and come up with my prime factorization and see if I can take anything out. So I can take out a 2 and I can take out a 3. So I end up with negative 4 plus or minus 6 square root of 2 all over 4. Okay. Once again, I have my fraction, so I can simplify that. And there's a shortcut you can take, and I'm going to kind of show you. As long as I reduce all 3, I only reduce what's outside of the radical. So 2 goes into 4, or negative 4, negative 2. 2 goes into here 3 times, and 2 goes into here 2. So I end up getting negative 2 plus or minus 3 square root of 2 all over 2. Now, I cannot simplify the negative 2 over 2 because 2 doesn't go into the 3. So I'm done. At this point, a lot of people try to say this reduces, but because you have a 3 here, this 2 doesn't count because it's not 2, it's square root of 2. You can't reduce this any further. So that is actually your simplified radical form solution to this equation. So just to sum up everything, the quadratic formula is a great option for solving quadratic equations because it works on all quadratic equations. However, you can tell by all of my work here, it's very long and it's very tedious and it's easy to make a mistake. So I tend to use the other options if they're possible, and they're fairly easy to use. I'll try the factoring, the completing the square, or use the square root property. But if I look at it and those seem too complicated, the quadratic formula is a great choice. Just be very careful with your negatives, be very careful with your simplification. And as always, the more you practice this type of problem, the better you're going to get at it.